Hello students, welcome to My Abhyas. My name is Sahana KS and I am your physics educator. So in this session, we will be starting with a new chapter, and that is nothing but the second year chapter, which is called as the electrostatic potential and capacitance. So in the last chapter, we have discussed about the electric charges and fields. How are the electric charges constant and how they influence the electric field, like what type of field will be developed and how does the charges react to each other whenever they are brought together. So in this session we will be learning about what is electrostatic potential, okay, in detail. I hope you people have studied this in your 10th standard, because there we have one chapter which is known as electricity, and there we come across the first topic itself, which is called as electric potential. So what is electric potential and capacitance? We'll be looking into that in the later stages. But today in this session, we'll let you know in detail about how and what is the electrostatic potential. Clear? So moving on to the next one. What is this potential? Okay. So now what I'll do is, I'll give you one example. Okay. What is the example? First thing. So, I'll take a tank. Okay. Next, what I'll do, I'll take another tank at the down. Clear? So this is empty. This tank is empty. And this tank is filled. Clear? Now, what I have to do is, I have to get the water from this tank to this tank. So what I'll do, I'll just put one hole here. Okay, one hole, I'll just put it. What happens? Automatically the water flows, okay, and as the water flows, this fills, right? So here I have not done any work except for what? I have just put a hole so that the transfer becomes easier, right? So in the next case, what I'll do is, I'll take a tank, okay, and another tank at the lower lower level, and one will be at the higher level. So now here I'll put the water again. I have filled it with the water. Now I have to shift the water from low to high. So what I'll do, I'll attach a motor. So generally we do this at home, right? Generally in home we do it. The shifting of water from the sump to the tank at the top, right? So I just fix a motor, and then what happens? The water transfers from low level to higher level. So here what I'm doing, I'm giving some external energy there, so that the water has to be pumped up, right? What I'm doing, with the help of motor, I'm giving a push so that the water has to go to the upward tank, right? So what is this motor doing? It is giving some sort of external force, right? So that external force, what it is doing? It is doing, or it is completing the work what I had imagined, right? The work is completed, or you can say the work is done, right? The work which I had thought, that of shifting the water from the down to the up level, the work is completed, and also it is done, right? So here, with the help of external energy, I am taking the water from the upward to the from the down to up. Now third case. Okay, in the first case we didn't use any type of energy, it was automatically done. In the second case, we used a lot of energy, like external energy or external force we used, so for the work to be done. And in the third case, what I'll do, I'll just take the two tanks. Okay, one tank is not there, like the water isn't there in that tank. The other tank is filled completely with water. Okay, now what I'll do, I'll just put a pipe here. Okay, once I connect a pipe with the tank A and to the tank B, what happens? The water starts shifting. Okay, as the water starts shifting, when will it end? When will the water when will it stop transferring from A to B? When the tank A and the tank B have the same level of water. Right. So when the water is constant in both the beakers, then what happens? The water flow is constant. Okay, I hope these three are understood by you, because these are all a live example. You can do it at home, right? So these are very easy to understand. Why am I telling this? Because electric potential, when I come, so when we say electric potential, then it is nothing but it is the work done. What is it? It is nothing but the work done. Everything will be related to the work done. Clear? So electric potential, or you can say electric potential energy. Okay. So these are the terms which you will be using in this chapter. And what is electric potential? Electric potential is, in simple words, it is the ability of a conductor, or you can say of any substance, to store that charges. Okay, whenever, like, whatever the transfer of charge may be, whatever may be the history of those charges, how did it come, how did it go, etc. But whatever the charges are there, and whatever the charges are, however the charges are behaving in that type of conductor, is nothing but we call it as the electric potential. Clear? So now moving to the exact point. What I'll do, I'll just keep a charge. So what is a charge? It is nothing but a basic quantity, right? So I'll just keep a charge here, which is plus Q. Okay. So obviously this charge gives out certain energy, right? That is certain field, electric field, you can see. So it will be having certain electric field. So after this, what I'll do is, in the next go, there is one charge which is at infinity distance. The distance of that charge is infinite. Okay. And that charge is at higher potential, or it is at the higher level. Okay. So this charge, I'll just name it as Q0. Now what I have to do is, I have to bring this charge near to this charge. Okay. There is some point P here somewhere. Okay. I have to bring this charge near to this charge. Okay. So what I'll do, I'll just keep the point P here only. It will be very easy for you to understand. So I have to do the work. What work I have to do? I have to bring that charge from infinity to the point P, right? So while bringing this charge Q0 near the point P, or to the prescribed point P, some work is done. Some work is done. So that work done, we call it as what? Electric potential. Okay. What do we call? We call it as an electric potential. Clear? So this is how electric potential is taken. Now, there is another important theory. What is the theory? So here again I have a point Q0. Okay. And here, here I have plus Q. Okay, so this is plus Q, source charge. Okay. And another charge, which is a test charge, is taken here at the point infinity. Now, what happens? I'll bring it near to this point. Okay, work is done, and I have brought it near to the point plus Q, or to the point A I'll take. Then, by hook or crook, what happens? That point Q0, whichever I have brought it near A, goes back. Okay, so goes back. Now what I have to do? I have to again bring it. So while bringing it, what happens? I'll do some amount of less work, you can say. The work done is a bit less, or maybe the point is not exactly taking. Okay, the point whatever I have considered is it is getting a bit replaced. So that time what happens? This is in the first case when I have bought the point charge, and then this is the second case. Okay, so this I'll take it as B position. So here what happens? When I took it from Q0 to A, there was the first work done, and that I call it as, that is electric potential VA. Okay, and then another point, that is when it went back. Okay, by hook or crook or something has happened and it has gone back, and again I have to bring that charge. I did again the work, same amount of work, or maybe increased amount of work, and I got the potential as VB. So after this, I have to find out the potential difference now. Why should I find out the difference between these potentials? Because I have to know how much energy has been, like how much potential has been there. So if I take the difference only, I'll get, right? So what I'll do, I'll just do VA minus VB. So that gives me the electric potential of the work done, right? So this is how potential difference is taken. Okay, how is it taken? It is taken VA minus VB. So now we'll look into the exact definition of electric potential. So what is electric potential? Electric potential is nothing but it is the charge when at infinity is brought near the prescribed point and the work done against the electric field is called as what? Electric potential. So here you can just see some introduction part. So why we have to study this chapter, okay? So for one thing, energy is conserved quantity. We know that energy is conserved and is thus an important tool for understanding nature. So energy is nothing but it is an important tool to understand the nature and also the laws of nature. We saw that many problems could be solved using the energy concept. So why are we talking about energy here? Because we come across an energy which is called as electric potential energy. So we have this that many problems are solved using this potential energy, kinetic energy and other forms of energy, right? So even though a detailed knowledge of forces involved was not possible. So there are a lot of forces involved, even that didn't give us so many results, but when we studied about the energy, there were huge number of results and they were accurate results. So on the basis of energy only, we are speaking about this chapter, and that is we call it as electric potential and capacitance. And at every point in electrostatic field, a particle with charge Q possesses electrostatic potential energy. So electrostatics means what? Static means constant. So constant, what is potential energy? Potential energy is nothing but it is the energy possessed by a body at rest. So you can relate, right? At rest, constant, right? So at rest, constant in the sense what? Whenever in an electrostatic field, a charge, if you see a charge, okay, a constant charge, then that charge is having, that is the electrostatic potential energy. It has the electrostatic potential energy. Clear? So I hope this much is clear to you. Okay. If you forget about the electric potential definition also, it's okay. Because I'll let you know in the next slide how to remember it, okay, and also about the potential difference. I'll just repeat it once again so that it will be very clear for you. So what are we studying here? We are studying here the work done. So that is the energy applied and also the forces and also about the electrostatic fields and the charges. Clear? So moving on to the next slide. Okay. So we have electrostatic potential. What is the definition of electrostatic potential? So the electrostatic potential at any point in an electrostatic field is defined as the work done in carrying a unit positive charge. Okay, what is it? A work done in carrying a unit positive charge, that is without any acceleration, from infinity to that point against the electrostatic force of the field. So what are they telling me in the definition is there is a charge, okay, which is plus Q. Okay, obviously if it is a charge plus Q, then it has electric field. What type of electric field? Which is the outward electric field, because plus Q charges give out outward lines of force, right? So when there is a point here which is at infinity and there is a charge. So that is Q naught charge I take. So this Q naught charge I have to bring it to plus Q. So if I have to bring it to plus Q from infinity to this point, this Q naught has to face a lot of issues. So what are those issues? First, at infinity it is, so there is no force of this charge. Okay. Then when I start bringing it, then what happens? The electric field around this charge